October 19, 2017, an automated alert flashed across screens at the Pan-STARRS Observatory in Hawaii. Something was racing through our solar system at 87 kilometers per second. Its trajectory, impossible. It came from outside, the first confirmed interstellar object ever detected. What astronomers saw through their telescopes would spark the most controversial debate in modern astronomy. Stay with me, because what they discovered is still dividing scientists today. Every single night, telescopes like Pan-STARRS scan the heavens, hunting for anything that moves, asteroids, comets, potential threats to Earth. The system is automated, precise, cataloging millions of objects as they drift through the darkness. Most of what these telescopes find follows predictable patterns. Asteroids orbit the Sun in neat ellipses, trapped by gravity like planets. Comets swing in from the outer solar system, their icy tails blazing as they approach our star, then loop back into the cold void. But there's always been a theoretical possibility that intrigued astronomers: objects from other star systems, interstellar wanderers, ejected from distant planets by gravitational chaos, drifting through the galaxy for millions of years. The math said they should exist. 1, maybe 2, passing through our solar system every year. But here's the problem: they move too fast. By the time you spot one, it's already leaving the window to observe. Days, maybe weeks if you're lucky. For decades, astronomers searched. They found nothing. Until that October night in 2017, when the first data came through, confusion spread quickly among the research team. The orbit didn't make sense. This wasn't another rock circling our sun. The trajectory was hyperbolic, meaning one thing: this object was just passing through. It came from somewhere else, and it was already racing away. The alert designated it a 2017 U1, just another code in a sea of astronomical data. At first, researchers assumed it was a near-Earth asteroid, routine. They'd seen thousands before. But when they calculated its orbit, something stopped them cold. This object wasn't orbiting the Sun at all. It was coming from the direction of Lyra, a constellation far beyond our solar system, and its speed, to 87 kilometers per second, exceeded the Sun's escape velocity. That meant gravity couldn't hold it. It would swing past our star once, then vanish forever into interstellar space. The realization hit like a shockwave. This was it, the first confirmed visitor from another star system. After double-checking the calculations and waiting for independent confirmation from observatories worldwide, astronomers gave it a proper name: Oumuamua. In Hawaiian, it means messenger from afar arriving first, and the messenger had brought surprises no one anticipated. As telescopes tracked Oumuamua across the sky, they measured its brightness, and that's when the first anomaly emerged. The object's light varied dramatically as it tumbled through space, brightening and dimming by a factor of 10. This pattern revealed something extraordinary. Oumuamua was shaped unlike anything we'd ever seen. The data suggested it was extremely elongated, roughly 400 meters long, but only 40 meters wide, a ratio of 10:1. Imagine a cosmic cigar, or perhaps a thin disk, spinning end over end as it hurtled past the Sun. No known asteroid has proportions like that. But the strangeness didn't stop there. When astronomers plotted Oumuamua's trajectory with precision, they noticed something unsettling. The object was accelerating. Not much, but enough to measure. It was deviating slightly from the path gravity alone would predict. This is classic comet behavior. As comets approach the Sun, ice vaporizes, creating jets of gas that push the comet slightly off course. But here's the problem: Oumuamua showed no tail, no glowing coma, no evidence of outgassing whatsoever. It was accelerating like a comet, but it looked like an asteroid. Then came the third mystery: its composition. Spectroscopic analysis revealed a reddish surface, highly reflective, but the data was inconclusive, and time was running out. Oumuamua was already fading from view. Astronomers had maybe 11 days before it became too dim to study. The race was on. Word spread through the astronomical community like wildfire. Within hours, telescopes across the globe pivoted toward Oumuamua: the Hubble Space Telescope, the European Southern Observatory, Gemini Observatory in Chile. Every major instrument that could get a glimpse was activated. Even the Breakthrough Listen project, designed to search for signs of alien technology, turned its attention to the mysterious visitor. They scanned for radio signals, anything artificial. But Oumuamua wasn't cooperating. Every day it traveled farther from the sun, growing dimmer, harder to see. Each passing hour meant less data, fewer answers. By January 2018, it had vanished completely from our telescope's view, lost in the cosmic darkness beyond Neptune's orbit. The window had closed. Now scientists had to work with what they'd gathered, and the mystery only deepened. With limited data in hand, astronomers began proposing explanations. 4 main theories emerged, each attempting to solve the puzzle. Theory 1. A natural interstellar asteroid. Perhaps it was a fragment ejected from a distant planetary system, shaped by ancient collisions into that bizarre elongated form. The acceleration may be just measurement error, but the shape was statistically improbable. Nothing in our solar system looked remotely similar. Theory 2. An exotic comet. Some scientists suggested Oumuamua might be made of nitrogen ice, like the surface of Pluto. This could explain the acceleration without a visible tail. The reflective surface, a layer of frozen material. Problem: the reddish color didn't match, and at that proximity to the sun, nitrogen ice should have vaporized noticeably. Theory 3. A natural solar sail. What if Oumuamua wasn't cigar-shaped at all, but extremely thin, like a disc or sheet, less than a meter thick? Pressure from sunlight alone could have caused the acceleration. But how would something so fragile survive millions of years traveling through interstellar space? Then came the 4th theory, the controversial one. Harvard astronomer Avi Loeb published a paper suggesting something that made headlines worldwide. What if Oumuamua wasn't natural at all? What if it was technology? An artificial solar sail, a probe, perhaps even debris from an alien civilization. The scientific community erupted in debate. When all observations were analyzed, here's what remained certain. Oumuamua's complex tumbling rotation confirmed. Its non-gravitational acceleration, 100% real, though small in magnitude. Radio emissions, infrared signatures, anything suggesting artificial origin, none detected. Its composition, still uncertain. Its origin, likely the direction of Vega, but impossible to confirm. The object had come, puzzled us, and vanished. So what's the final verdict? Today, most astronomers lean toward a natural explanation. The leading theory, published in 2020, proposes something elegant, a hydrogen iceberg, molecular hydrogen ice, H2, forming in the frigid heart of interstellar clouds where temperatures hover near absolute zero. Here's why it works. As Oumuamua approached the sun, this exotic ice would sublimate, releasing invisible hydrogen gas. No visible tail, no glowing coma, just enough thrust to cause that mysterious acceleration. It explains nearly everything. The bizarre shape, still debated. Perhaps it's a fragment from a shattered planet, broken in some cosmic collision eons ago. Meanwhile, Avi Loeb maintains his position. He argues the evidence doesn't rule out artificial origin, and science should remain open to extraordinary possibilities. Most astronomers respectfully disagree, insisting natural explanations fit the data. But here's what everyone agrees on. Oumuamua challenged our assumptions. It forced us to think differently. Sometimes the universe doesn't fit our expectations, and sometimes the simplest explanation takes years to find. What Oumuamua proved beyond doubt is this: interstellar objects regularly visit our solar system. Updated estimates suggest 1 or 2 pass through every year. Most go unnoticed, too faint, too fast. In 2019, we confirmed a second visitor, 2I Borisov. This one was clearly a comet, familiar, predictable, almost boring by comparison. It followed the rules. But that's the point. The universe is far more dynamic than we imagined. Star systems don't exist in isolation. They exchange material constantly. Rocks, ice, perhaps even organic molecules drift between the stars. We're part of a galactic ecosystem. Now, astronomers are preparing. The Vera Rubin Observatory, operational soon, will detect dozens more interstellar visitors. Missions are being proposed to intercept the next one, to land instruments, to study it up close. We have perhaps 5 to 10 years to prepare. The universe reminded us that every discovery opens new questions. and Oumuamua's greatest lesson. We're just beginning to understand our cosmic neighborhood. Oumuamua came and went in the blink of a cosmic eye, but its impact on astronomy will last forever. It proved that our solar system isn't isolated. We're part of something bigger, a galaxy where worlds exchange pieces of themselves across unimaginable distances. Every telescope pointed at the night sky is a window into the unknown, and the next interstellar visitor could arrive at any moment. When it does, we'll be ready. So here's my question for you. What do you think Oumuamua really was? A hydrogen iceberg tumbling through space? Or something more exotic? Drop your theory in the comments. I want to know what you think. If this story fascinated you, hit that like button. Subscribe for more cosmic mysteries, because next time, we're exploring fast radio bursts, signals from deep space that shouldn't exist. Keep looking up. The universe has more surprises waiting.